In this video, I will show you how to find the equation of a plane. So here is the formula that we're going to use. So the formula is the n vector, the dot product of the n vector with, in the bracket, p minus p naught equals to 0. So here is the formula to find the equation of a plane. So what is the n vector? So the n vector is a vector which is normal or perpendicular to the plane that we need to find. So the n vector is a vector which is normal or perpendicular to the plane, and p is the variables of x, y, and z, and p naught is a point on the plane. So here we have the two most important information that we need, which is the n vector, which is a normal vector to the plane, and then we need a point on the plane. So this is the two most important equation that information that we need in order to find the equation of a plane. So in our studies, we'll look at three cases. There are three types of cases that we're going to look. So for case number one, or the first scenario, this is the easiest scenario, which is given given a point on the plane. Later on, I will show you one by one on the plane and a normal vector, a normal or perpendicular vector. So this is the easiest one, which means that the P naught is given, a point on the plane, and a normal vector, which is the n vector. The normal vector is given. So we can straightforward, if this case, we can straightforward substitute this information into this formula. This is the most easiest scenario. So kat sini, case number 1 ni paling senang lah. Dia bagi satu titik dan satu normal vector. So kita boleh direct ganti saja. This is the most easiest scenario. We have the second case. Then we'll look at the second case, case number 2, which is given a point on the plane. A point on the plane and a line on the plane. Given a point, or I can write as given a point and a line on the plane. So given a point and a line on the plane. So you can see that in the second case or the second scenario, a point is given, just like case number 1. But in case number 2, the normal vector is not given. It's just given a line on the plane. It's not a normal vector. So in case number 2, we have to find the normal vector. So how are we going to find? We're going to find by using, actually we are using the cross product. If you still remember, if you try to find the cross product of two vector, then the output mean that the vector that we're going to find is perpendicular or orthogonal to the other two line. If you still remember, that's why we're going to use the cross product. So in case number 3 is given two lines. Let's say L1, line number 1, and L2, line number 2 on the plane. So this is the second case. And finally, case number 4. The last scenario, which is given 3 points on the plane. So this is what we're going to learn in this subtopic, which is finding the equation of a plane. So here is the formula. The n vector, which is the normal vector to the a vector normal or perpendicular to the plane. N vector is the vector that is perpendicular or normal to the plane times dot product with the bracket p minus p naught, where p is the variables x, y, and z. P naught is the point on the plane. And there are four cases that we're going to consider in this subtopic. So the first scenario is the given a point on the plane and a normal vector. See, so this is the easiest scenario where we can straightforward substitute the p naught and the normal vector. In case number 2 or second scenario, given a point and a line on the plane. The third scenario is given two line L1 and L2 on the plane. And case number 4, given 3 point on the plane. You can see that in order to find the equation of the plane, we need the normal vector. Except case number 1 or the first scenario, the second, third, and fourth scenario, we need to find the normal vector. And normally, we're going to use cross product to find the normal vector. So in the next video, I will show you case by case. So that's it for this video.